Okay, so today we're going to continue with the chain rule. And so I guess I need to tell you that, and I think I told you this last time, that there are two versions of the chain rule, depending on upon the type of derivative notation that you used. We learned the one that we learned last time had to do with the composition notation, or variable notation it's called. So today we're going to talk about, we learned about the function notation version last time. Today we're going to learn about the variable notation method. So I'm going to put us into the writing mode. Okay, writing mode failed. There we go. Okay, so we've learned about the function notation version. So what is the function notation version? Well, if you want to, there we go. If you want to take the derivative of a composition and you write that composition using function notation. Okay, so remember, like, what's function notation? Where you have like f and g, those are functions. So I'm taking the derivative of f composed g. So the chain rule says, hey, what do? You take the derivative of the outside function, leave the inside function untouched, multiply by the derivative of the inside function. Okay, so that's function notation. Okay, so the first, eventually we're going to talk about another way to write this, which we'll use variable notation. We'll cover that in a little bit. Okay, but first what we're going to do is extend the chain rule. So right now, we can deal with one composition. Between two functions. We are going to extend the chain rule to two compositions between three functions. Okay, so what do I mean by that? So what I mean is, okay, one composition deals with two functions. You can do something like f compose g, or f of g of x. One way you would normally write that is like this. That's how you write f compose g. Notice that there's one composition. You're feeding a g into an f. But you need two functions to do that. So a composition requires two different functions. So if you have two compositions, you can pull that off with three functions. So what you could do is you could do f, let's write this. You can do f compose g, and then you can compose that again with h. And the way we would normally write that is like this. The h of x, you start there, and that gets fed into some function g of x. That's a single composition. And then that gets fed into another function f of x. So you have f of g of h of x. There's two compositions there with three different functions. Okay, so the way we would write this is we would say, you're going to compose g with h, and then you're going to compose that with f. Okay, so what if you want to take the derivative of something that has two compositions like that? So how do you take the derivative of this? So you want to take the derivative of f of g of h of x. Okay, so what you do is you can actually do this with the chain rule. So our outside function is going to be f And then our inside function is going to be all of that stuff. Okay, so the chain rule says take the derivative of your outside function, which is f prime, and then just plop in the inside function, g of h of x. And then what are you supposed to do? Multiply by the derivative of the inside function. So I'm just going to write here that I'm taking the derivative of the inside function. Now what you can notice is that you can use the chain rule again to calculate this derivative here. Okay, again, you have an outside function. Your outside function in this case, however, is this time is g. And you have an inside function, which is h. So when you compute this derivative, the derivative of the outside function is g prime. You leave the inside function h. And then you multiply by the derivative of the inside function, which is h prime. And then we need to recopy our original work, our f prime of g of h of x multiplied by this stuff. Okay, so let's look at what happened here. When you had three functions, you started with your outside function, took its derivative, and then you put the inside. And then you dealt with the inside. You took, for this inside part right here, you took its derivative, g prime, and you took the inside and left it in there, and then you multiplied by the derivative of the inside. Okay, so this works for no matter how many functions you have. You can basically keep unrolling it. Like if you wanted to take the derivative of the composition of four functions, so f of g of h of k of x, you'd start with your outside function, f, and you'd take its derivative, and then you would put all of this inside stuff. Okay, and then what are you going to do? You repeat the process. You take the derivative of this outside function for what you're dealing with here. So I'd have g prime, and then you'd have to multiply by the inside. Or, sorry, compose with the inside. And then now you work with that. You look at that part and you're like, that's my outside function. You multiply by the derivative of that, and you leave what was inside of it. Okay, can't find my blue, there it is. Until you get to one last thing in here where you're like, okay, I take the derivative of that, and then now you're at the end. So do you see how each time it gets one smaller, basically? You take the derivative of the outside function, leave what was inside, then work with what's inside, take the derivative of the outside one, and you keep on reducing down, and they get smaller each time. So that's like sort of a pattern that you can follow. So let me show you how you actually would use this. But I guess before we move on, I want to know if there are any questions. Do we see the pattern in terms of how you start with the outside function, you take its derivative, and then you keep on like peeling off the inside parts? Let's do an example then. So example, let's find the derivative of, here, I'll write this. cosine to the fourth of 7x squared plus 1. Okay, now really we should rewrite this. It's the cosine of 7x squared plus 1, all raised to the fourth. So I'm gonna break this down so you can color code it. Okay, the last thing we do is raise to the fourth. What gets raised to the fourth? The cosine of 7x squared plus 1. Now, so let's put all of that is raised to the fourth. Now, how do you do this? You take the cosine of something. The something that you're taking the cosine of is 7x squared plus 1. Okay, so this is your inside function. And then the being raised to the fourth is the most outside function. So I have three different functions here. I have f of g of h of x. F is the most outside, it's the thing that happens last. H is the most inside, it's the thing that happens first. And then g is I don't know, we'll call it the middle function. Okay, so the thing that you do first, the inside function, is 7x squared plus 1. Now, what does that get fed to? Oops, that should be h. Oh, we haven't taken any derivatives yet. I'm just identifying what the three functions are. My inside function is 7x squared plus 1. Then what does that go to? My middle function, g, which is cosine. And then what's the last thing that happens to anything? That's the f of x. Everything gets raised to the fourth, so you get x to the fourth. So I want to verify that f of g of h actually is cosine to the fourth of 7x squared plus 1. So let's look at f of g of h of x. So what I like to do is that you have to start from the beginning. You want f of g. Now what is your h? Your h is 7x squared plus 1. Okay, 7x squared plus 1 is being fed to g. What does g do to anything? It takes the cosine of it. So you have the cosine of 7x squared plus 1. And then don't forget that all of that was in the f. Now what does f do to anything? It takes it and raises it to the fourth. What are we raising to the fourth? The cosine of 7x squared plus 1. So you can see that that matches with what I started with, right? That's how I know that I chose the proper f, g, and h. Okay, so I want to pause and I just want to know if that makes sense to people about how I chose f, g, and h. Or if there are questions about that. Okay. So now we can take the derivative. Remember, the chain rule says if you want to take the derivative of f of g of h, you first take the derivative of f and you leave g and h by themselves. Then you work on the inside of that. You take the derivative of g, you leave h, until you get to the last thing here, to multiply by the derivative of h. Okay, so now we need to know, let's work backwards. We need to know what's the derivative of h. Well, h is 7x squared plus 1, so what's the derivative of h, or h prime? H prime is 14x. Okay, and then now for this part, I need g prime of h of x. Well, what is g prime? What's the derivative of cosine? Yeah, so g prime is minus sine. So I'm going to have the minus sine of h of x. H of x is 7x squared plus 1. So I have g prime of h of x. Remember, the g prime is the minus sign. And then inside of the minus sign, you need your h of x, which is 7x squared plus 1. Finally, I need f prime of g of h of x. If f is x to the fourth, then x prime is 4x cubed. So I'm going to have 4 something to the third power. Now what's going to be inside of there? G of h of x. That's going to be the cosine of 7x squared plus 1. So notice anything that has to do with h, I color-coded in red. Anything that has to do with g, I color-coded in blue. Anything that has to do with f, I color-coded in green. Regardless of whether it was f, g, or h, or f prime, g prime, or h prime. So what have I found? This here that is my answer. It is the derivative of cosine to the fourth of 7x squared plus 1 using the chain rule for 3 compositions. But are there questions on how I got the different parts? How I found f, g, or h? Or how I used the formula to plug everything in? Okay. Well, I guess this is a good time to take a break.